So X-rays really shows us that the universe is very energetic.
We find X-rays in jets, erupting from the centers of active galaxies. We use them to measure the spin of black holes or supernova explosions. It takes a powerful event to produce cosmic X-rays.
Sometimes people also call it the hot universe because, when you have this gas in galaxy clusters or also around galaxies that you can see only in X-rays, this gas is about 10 million to 100 million of degrees, which is so hot that this gas does not radiate in optical, does not radiate in infrared, but it only radiates in X-rays.
To further understand these hottest regions, we need the next generation X-ray telescope. The Japan Aerospace Exploration Agency, or JAXA, is partnering with NASA and the European Space Agency to launch the next generation X-ray space telescope. The telescope, called XRAY, launches from the Tanegashima Space Center at the southern end of Japan on an H-2A rocket. The spacecraft weighs over 5,000 pounds, stands over 30 feet tall, and will orbit approximately 340 miles above Earth. We're familiar with the medical uses of X-rays. X-ray light is energetic enough to pass through our skin. Our calcium-dense bones absorb that light, blocking it from reaching the detector and creating a shadow. Luckily for us, X-rays from space don't make it through our atmosphere. But what that does mean is that we have to send X-ray hunting missions into orbit to detect this high-energy light. XRAY also needs special kinds of mirrors, which were built at NASA's Goddard Space Flight Center.
The type of the mirror is called a nested mirror. It looks like a cross-section of the onions.
X-rays are so energetic they fly right through typical mirrors.
For the visible light, we typically place the mirror like this, so that light just bounces back. But for the X-rays, this doesn't work, so that we put the mirror like this, so that X-ray just graze surface of the shell.
When they strike mirrors at very shallow angles, X-rays too can bounce.
And then so we made it like a conical shell like this, then X-ray can be directed.
XRAY has two instruments, each with their own mirror assembly. One for imaging, called Extend, the other for spectroscopy, called Resolve. JAXA built Extend to provide XRAY with a wide field of view. It can observe an area about 60% larger than the average apparent size of the full moon. NASA's Resolve instrument is a spectrometer that splits X-ray light, like a prism, so scientists can detect specific elements present in the sources they're studying. It uses a small 6x6 pixel detector called a microcalorimeter, nestled in a refrigerator-sized container of liquid helium. Resolve will measure the small temperature changes caused when X-rays hit one of those pixels. To track such small temperature changes, Resolve's detectors must be kept extremely cold. That liquid helium cryocooler will keep the instrument at 0.05 degrees Kelvin. It's so cold, it is a fraction of a degree above absolute zero. Heat is simply a product of moving atoms. Keeping Resolve's detector that cold means that the atoms barely move. So there's very little thermal noise in the system. It's what keeps these accurate measurements possible. Each X-ray detected will help scientists pursue many questions about the hottest regions of the cosmos. What's happening in the extreme gravitational fields around black holes? Can we discover what is inside a neutron star? How did some of the universe's largest structures, like galaxy clusters, evolve?
Optical telescope, you will just see galaxies everywhere. If you look at this same cluster of galaxies in X-rays, you will see actually a lot of gas. And this gas, it constitutes actually most of the matter, the cluster of the galaxies, which is something extremely important to understand, because it means that most of the matter in the universe is not in the form of planets or stars, but it's really in the form of this gas. But XRAYism really has this capability of decomposing this X-ray light in a way that's much, much more accurate than what has ever been done before.